An ongoing major landslide in Norway has just greatly accelerated, with 5 million cubic meters of rock yesterday moving 1.5 centimeters in a single hour. While this might not sound like much, this is roughly equivalent to the amount the same massive rock would normally take 8 months to move, implying an acceleration of roughly 5,800 times its normal motion. This accelerated motion was not merely confined to a single hour, with much of yesterday and today so far recording a rate of at least 1 centimeter an hour of motion. It should come as no surprise that this motion has already led to a number of small rock slides in the past week, which I have geolocated to have involved large boulders which tumbled as much as 775 meters, or a whopping 2,543 feet from their starting point only minutes prior. There is now a danger that more than 1 million cubic meters of rock, or in a worst-case scenario, the entire unstable mass could collapse all at once, running out and burying the landscape for multiple kilometers. However, this is a worst-case scenario. It is far from a certainty or even a likelihood, at least based on our current understanding of the ongoing situation. Also, landslides can sometimes speed up or slow down due to various factors without resulting in a catastrophic singular collapse. For example, take a look at Alaska's Arm Landslide, which has produced multiple but temporary increases in its motion that has so far not resulted in a major collapse. This is why the north slope of Skarfjellet mountain is now being actively monitored by radar, which will give us highly precise measurements to more accurately understand the progressing situation. And as I am writing this video, it appears that the landslide motion has slightly decreased hour over hour, but is still absurdly high compared to its normal motion. But first, what factors could be causing this ongoing landslide? The long-term answer to this question is probably primarily regional permafrost thaw, where previously solid and rock-hard patches of ground that were frozen year-round are now only seasonally frozen. This thaw from rising world temperatures has loosened the bonds between patches of previously well-connected soil until eventually in its thawed state it cannot hold up the massive rocks adjacent to or above it, causing a landslide to take place. However, the landslide at Skarfjellet mountain has been known and slowly ongoing for many years, so what caused the sudden escalation in its motion? Well, both rainfall, especially heavy rainfall, and a rapid change in temperatures have been linked to accelerations at monitored landslide sites worldwide. You can probably guess which is the culprit here, especially because it's occurring during the hottest month of the year locally, July. As, yesterday, when a notable acceleration to the landslide occurred, temperatures reached their all-time record-setting high of 26.7 degrees Celsius or 80 degrees Fahrenheit at the base of the unstable slope. Analyzing what might happen next at this landslide is far less clear-cut and obvious than it was in the case of the Switzerland landslide that ended up destroying Blatten. Regardless, people need to currently stay away from the immediate vicinity of the ongoing landslide for the time being. And, in my opinion, I'm concerned that a particular hazard might be underestimated: the chance of a portion of a hypothetical worst-case scenario landslide traveling further to the east than expected, partially then entering a local lake. If that were to occur, it could generate a localized tsunami that inundates existing structures on the lake's eastern end, but once again what I just said is highly speculative and unproven. A major landslide could also theoretically temporarily block portions of 2 local rivers and thus result in flooding hazards further downstream, but let's not get ahead of ourselves, as what I just said is a big if. Stay tuned for more updates. As a final note, I would like to thank this channel's patrons on Patreon and channel members on YouTube for supporting my work.